In this video, I'm going to show you two different problems. One is a combination problem and the other is a permutation or a fundamental counting principle problem. The first problem states John is studying photography and he was asked to submit 7 photographs from his collection to exhibit at the fair. He has 14 photographs he thinks are show-worthy. In how many ways can the photographs be chosen? This problem is a combination problem because nowhere in the problem does it state or imply that there's an order to the pictures being displayed, or a best picture, second best picture, or any sort of ranking. It's kind of like a jury selection problem. He just wants 7 photographs chosen from 14. So for this problem, it's a combination. Again, order doesn't matter. We use the formula 14 choose 7, and you could use that formula by hand, or you can use your calculator. To put this into the calculator, I'm going to put n in first, which is 14. Go to my math menu, right arrow over to probability, and option 3 is n choose r. And then I need to put in r. In this case, that's 7. So there's 3,432 ways that he can choose 7 photographs from 14. The second problem says there are 27 horses competing in a show. And how many ways can the blue, red, and yellow ribbons be awarded? Now this problem is not a combination problem because order does matter. There is a ranking, an ordering, a first place, a second place, third place type of problem. Okay, so using permutations, I could definitely plug into the permutations problem formula. There's 27 objects and I want to permute 3 of them because I've got blue, red, and yellow. Okay, so there would be 3 positions there. So that's going to be 27 factorial over 27 minus 3 factorial. Almost identical to the combinations formula, except for the fact that in the combinations formula we divide out all of the permutations of that object because order does not matter. All right, so I'm going to put this in my calculator. Very similar process to getting a combination. I'm going to put in n first, the total number of objects, and that's 27 horses. I'm going over to my math menu, over to probability, and option 2 is NPR. So I need to put in R, which is 3. And then we have 17,550. Alternatively, you could treat this as a fundamental counting principle problem when repetition is not allowed. So using the fundamental counting principle, I'll abbreviate that with FCP. I have 3 slots to fill with horses. I've got the blue ribbon, the red ribbon, and yellow. I'm assuming that's first, second, and third. So when we're looking at the slot for blue, nothing has happened previously, and we could theoretically fill that in 27 different ways because there's 27 different horses. But one horse gets the blue, so there's 26 left. In other words, the same horse can't earn a blue and a red ribbon. And then using the similar reasoning, we have 25 horses left for the yellow. Again, we can't have the same horse getting all 3 ribbons. So if you put that in your calculator, you'll see that you get the same answer.